All right, let's get started. Welcome back. Long time no see. Are you having fun with collaborative filtering? You don't remember that you did it so long ago, right? That's good. I read this blog from the folks at Netflix last week that says that they, for the first time, they reveal a bunch of stuff about how their collaborative filtering system works. It's actually pretty interesting. Not just the machine learning that depends on what have to happen. But the single thing in there that kind of struck me the most is they say that about 75% of everything that people watch comes out of the recommendation system. This is how important it is to their business. 3/4 of everything that people watch comes out of it. The other thing that was striking was the size of data sets that they're applying things to. Right, one of the main jobs has been to scale up algorithms like the ones that were in the Netflix competition to 5 billion ratings. That's a slightly bigger project than the one that you're doing. But at heart, it's all the same, right? So now you know how to do it. Okay, so in the meantime, today we're going to talk about one of the largest and most intensively researched areas of machine learning. And in fact, these days you could say it's the core, right? They're a big piece of the core of machine learning. And this is what's known as Bayesian Learning. Bayesian because it's based on the famous Bayes theorem, or more generally, statistical learning. Okay? And there's a lot to cover. You're going to learn a lot today. So here's a preview of what we're going to talk about. So first of all, we'll review Bayes theorem, and we'll see what an MAP learner is. MAP is short for maximum a posteriori. And maximum a posteriori means you want to return the hypothesis that is most probable after you've seen the data. This is what a posteriori means. We'll see the notion of a Bayes optimal classifier, which is a theoretical notion, but it's a very important one. And then we'll look at one concrete practical learner, which is naive Bayes, which is, of course, the algorithm that span filters are, or at least traditionally have been based on. And in this, we will see how to apply naive Bayes to text classification, which is what span filters do. In fact, this is what a big chunk of your third assignment is going to be. So for those of you who are already done with collaborative filtering, tonight before you go to sleep, you can do your span filter, and that's a good chunk of the assignment then. And then we will look at a more powerful type of Bayesian learning than naive Bayes, which is learning Bayesian networks. And then we will look at finally, we will look at one of the most famous algorithms in all of machine learning, which is the EM algorithm. Okay? The EM algorithm is used, it's really an algorithm schema. It's used for a very wide variety of things, so it's definitely very well worth your
microphone on, Pedro?
Pardon me?
Is your microphone on?
Oh, I assumed it was on. You folks at Microsoft hear me? I guess yes.
Kind of.
It's not very loud. Kind of low.
How do I tell if it's on or not?
You should see something on the front.
Yeah, I don't see anything. Oh, yeah, it is on. So shall I repeat or?
Oh, they could hear you. The room mics were picking up. It'll just sound better now.
Okay, all right. This was a little experiment in learning from noisy data. Right? This is so that you have a sense of what machine learning really is like, right? There's all this noise, and then there's this sweet signal, and you're trying to pick up the signal from the noise.
I think the UW slide missed out on it.
The what?
The UW slide missed out.
I know. Yeah. So see, these are the advantages of remote learning. Yeah, you get a more full experience of what machine learning is all about. On the other hand, you're also less prone to hallucination if you have a higher signal-to-noise ratio. So, okay, so Bayesian methods actually play two important but very different roles in machine learning, and it's important to be aware of them. And some of what we're going to be doing here is for one role, and some of it is for the other. The first role is as a set of learning algorithms. Right? There's many practical learning algorithms that naive Bayes that come out of Bayesian learning. And these algorithms have, they include things like naive Bayes learning and more generally Bayesian network learning. They have a very important feature for our purposes that they're going to give us a new way to combine prior knowledge with data. Right? We saw in the very first week that machine learning is not just about the data. You have to bring some knowledge to bear. And the easier it is to bring that knowledge to bear, the more likely your machine learning will do well. Right? And then when we studied rule induction, we saw one way of providing that knowledge, which was to, just state things in the form of rules or first-order logic. Okay? But one of the big advantages of Bayesian learning is that it provides a different way to encode prior knowledge. In particular, in the form, as we'll see, of prior probabilities. So we're going to see what prior probabilities are and how we can use them to encode prior knowledge. But the other main role that Bayesian methods play is actually different from the things that we've seen so far, is that you can use Bayesian methods as a way to analyze any learning algorithm. So for any learning algorithm that we've seen so far and that we're going to see in the future, there's the Bayesian version of that. You can learn decision trees the Bayesian way. You can have Bayesian instance-based learning. You can learn rule sets the Bayesian way. So Bayesian methods provide a way to answer questions like, how well is this learner really compared to the best that you could do? So they provide a gold standard, which is the Bayes optimal classifier. And the other thing they let us do is they let us analyze an algorithm. And analyzing is a help to maybe coming up with a better version. Okay? So these are the two roles of Bayesian methods, and we're going to see some examples of each. And as always, if you have questions at any moment, please feel free to ask them.